All right, and we are back for section 10.8. That'll be the third and last installment on this section. You'll notice that the math in here is not necessarily difficult, but it does take some time and practice to become comfortable in working with imaginary numbers. So let's take a look at what problem is in store here for questions like 66. So the directions in a question like this is we're going to be asked to write these numbers in a plus bi form or in complex form. So they're not going to necessarily direct you to use the conjugate to simplify this. So we have the number 26 over 5 plus I. And what we notice here is we have a number in complex form in the denominator, or in a plus bi form in the denominator, but the expression itself is not written in a plus bi form. In order to get it in this form, what we are going to do is to multiply by the conjugate on the top and at the bottom. So if we have 5 plus I in the bottom, we're going to write here as 5 minus I. And we're going to put that in the bottom, and we're going to put that in the top. So the idea is we just want one number on the bottom. And remember that when we multiply by the conjugate, we only need to multiply the first and the last term. So when we do this, let's see what happens now. We have 5 times 5. That's going to be equal to 25. A positive I times a negative I. Well, that's interesting. But a positive times a negative is going to be negative. I times I is going to be I squared. Okay. On top, we're going to have, and probably would be a good idea to put parentheses around all this, we're going to have 26 times the quantity of 5 minus I. So we'll go ahead and kind of simplify along the way on the top here. Well, 26 times 5 is going to be 105. 26 times negative I is going to be minus 26I. On the bottom here, we're going to have 25. Well, we know this is going to be minus. We know this is I squared, so it's going to be minus I squared. Again, we'll kind of extend this down a little further to kind of show each step along the way. So we can't do anything to the top at the moment, so all we can do is just write it as 105 minus 26I. The only thing I can do at this time is I can take the I squared and I can replace I squared with negative 1. In doing so, that's going to give me, and forgive me for going in through every step, I want to make sure this is clear to everybody in my viewing audience. This is going to be 25 plus 1, because minus and negative is the same as subtraction. So this is going to give me 105 minus 26I over 26. So what you notice here, and one thing I probably could have avoided if I didn't do the multiplication in the beginning, is I can, if I want to at this point, I can take that 26 that I multiplied through and kind of start with what I did. So I have 26 times 5 minus I, which, where do I get that from? I get that from this calculation here. I divide by 26, and these are going to reduce, leaving me with my final answer of 5 minus I. Now, that's not something you can commonly do, but the whole idea is we want to simplify this answer as much as possible. So, whereas this is a problem you can encounter, it's not a normal characteristic problem that you encounter. So let's go ahead and take a look at a more normal type problem about what you may encounter. Let's go ahead and take a look at 68. So this is going to be 4 over 2 minus 3I. And again, I want to write this in a plus bi form. Not with the denominator, but everything. So I'm going to multiply the top and bottom by the conjugate, which is 2 plus 3I. And let's see how we carry out the multiplication now. So this is going to result in 4 times the quantity of 2 plus 3I. At the bottom, remember, all I need to multiply the first, which is going to be 2 times 2, which is 4. And then the last, which is negative 9I squared. So I'm going to, in the next step at least, kind of cut to the chase, in the bottom especially. 4 times 2 will be 8. 4 times 3I is going to be plus 12I. I know I squared is equal to negative 1, and that negative 1 times negative 9 is going to be positive 9, so it's going to be 4 plus 9 or I can write this as being equal to 8 plus 12i over 13. Well, we're almost there in a plus bi form. So what I need to do with this point is I need to split this up so that it reads the following way. 8 over 13 plus 12 over 13i. In that case, a is equal to 8 over 13. B is equal to 12 over 13. And that is the number as is written in complex form, or a plus bi form. And that is typically the type of calculation you will need to perform to simplify that problem. So let's go ahead and take a look at just one more question here. No, we won't use this page. We're going to go ahead and use the back of this page here to conserve paper. And let's take a look now at question number 70. Just a little more work than what we've done before. So we have 3i over 4 plus 2i. And again, I'm going to multiply the top and bottom by the conjugate. It's going to be 4 minus 2i. 4 minus 2i. And again, it may help to have parentheses for all this here. So that's going to give me 3i times the quantity of 4 minus 2i. And here I can just multiply my first and last terms. 16 minus 4i squared. So let's kind of consolidate this a little bit. 3i times 4 will be 12i. 3i times negative 2i will be negative 6i squared. On the bottom, we're going to have 16 plus 4. Now, pay attention to what's going on top, because we've got this negative 6i squared here. I'm going to change things around a little bit, you'll see. So we still have 12i. The negative 6i squared is going to become plus 6. The bottom now is going to become 20. Now, one thing you got to pay attention to is now the I term is first. Or it used to be, it wasn't there before, but now it is. So we're going to need to switch this around a little bit. So I'm going to write this as 6 plus 12i over 20. And now I want to kind of expand this out and see if I could simplify this a little bit. So, well, let's see, 6 and 12. I want to be able to reduce this with 20. Well, let's just do it like this, I guess. So we're going to write this as 6 over 20 plus 12 over 20i. Well, 6 over 20 I can write as 3 over 10. And 12 over 20 I can write as 3 over 5i. And now we have this answer written in simplified form. So notice, I didn't try to find a common factor and then reduce it. I'm trying to write this in as simplified as I can. So I did the division of this I did the separation of this first, and then I divided each term. So that you notice that the A term is equal to 3 over 10, and that the B term is equal to 3 over 5. You notice that the denominators aren't the same. Well, that's okay. So this is going to be our final answer for a question like 70. So we'll go through a few more of these before we go through the last set of rules for working with those whole number exponents for I. Let's go ahead and take a look at a problem like 74. So here we have 2 plus 7i divided by the quantity of 5i. So we can make this a little more complicated. We can make this a little more robust. Really, all we want is to get rid of the I. We don't have to get rid of the 5 below. And it's not a binomial, so we don't have to multiply by the conjugate, but we do need to get I out of the denominator. So all I'm going to do is just multiply the top and bottom by I. That's it. That's all I need to simplify here. So go ahead and rewriting out this expression. We're going to have I times the quantity of 2 plus 7i over 5i times I. So just kind of writing everything out nice and neatly here. So I times 2 will give me 2i. I times 7i will give me plus 7i squared. 5i times I will give me 5i squared. So as I have this, this is going to give me now, let's see, 2i plus 7i squared will become negative 7. 5i squared is going to become negative 5. So what we're going to do is just keep the negative down there for the moment. We're not going to try to worry about getting rid of it onto the bottom until we separate this out. So remember, we have to write this in a plus bi form. So I'm going to need to reverse the top again and write this as negative 7 plus 2i over negative 5. Now, once I separate it into two fractions, hopefully it's going to become clear how we address the negative at the bottom. 210, and all I'm going to do for the moment here is write this as 2 over negative 5i. What you notice here is that negative 7 divided by negative 5 is going to be positive 7, 5. Then we have 2 divided by negative 5, so it's going to become minus 2 over 5i. So our final answer here is going to be 7/5 minus 2/5 I. And that is how we simplify a question like that. So a question that looks pretty innocent. Now, I'm very careful about going through all these steps. You don't have to do all these steps, but in learning this, I would probably caution you to try and do as many of these as possible. So let's take a look at two other questions here before we go to the last part of the lesson here. Let's go to question number 78. And this time we're going to have a binomial on the top and a binomial on the bottom in complex form. So it's going to be 5 plus 3i time over 7 minus 4i. And what's going to happen here, again, we're going to need to multiply it by the conjugate, but what makes this more complicated is we already have a binomial on the top. So it's going to be 7 plus 4i, 7 plus 4i. So where the bottom is going to be easy to simplify, the top is going to be a little more work. So here, 7 times 7, we'll do the bottom first. This is going to be 49. Negative 4i times positive 4i will be negative 16i squared. I know that I have 5 plus 3i times 7 plus 4i. So I'm going to go ahead and just start that work over here to the side. I'm trying to save room so I can fit one more problem on this page before I begin the next part of the lesson. So there's going to be 5 plus 3i, and then 7 plus 4i, or 7 plus 4i, that's right. So this is going to be 35. This is going to be 21i. This is going to be 20i. And then this is going to be 12i squared. 12i squared is going to become negative 12i. Just putting that outside of the box, I'm out of room. Or it should be negative 12. Not anything with I. 12i squared will be negative 12 because that becomes negative 1. So 35 minus 12, that's going to become 23. 20i plus 21i is going to be plus 41i. So I'm going to put it in exactly like that. 23 plus 41i. And we have the top now simplified as much as we can, but we still have to put this in a plus bi form. So I need to do a little more simplifying down here. So it's going to be 23 plus 41i over 49. Now minus 16i squared, this is negative 1. Negative 1 times negative 16 is going to be plus 16. So that's going to result in 23 over 40, or plus 41i over 65. And we'll add these two together. Now I'm going to split this up. So it's going to be 23 over 65 plus 41 over 65i. So that's how you carry out a question like that. And just be aware that when you have a binomial in the numerator and you have to multiply the conjugate, you're going to have to do some foiling of this in order to try to calculate and simplify this. So watch your work on here, especially the signage. The multiplication itself isn't complicated, but students, still struggle with understanding the idea of I squared being equal to negative 1 and then working out the signage through on that. So let's go to the last part of the lesson tonight, and we're going to talk about the concept of what we do with the cycle of I. So the last part of the lesson tonight is going to be on the cycle of I. So we already know that we have the square root of -1 equaling I. We also know that I squared is equal to -1. Okay? But what's I to the third? So we know that we can write I to the third as I to the second times I, because this is 2, this is 1. So we also know that I to the second is equal to -1. So I can write I to the second as -1 times I, or I could simply say that I to the third is equal to -I. Okay, so I to the third is going to equal -I. We know that I to the second is equal to -1. Now, what's I to the fourth? Well, I can write I to the fourth as I to the second times I to the second. That's the easiest way to think about this. And we already know that I to the second is equal to -1. I to the second is equal to -1. So we have -1 times -1. I to the -1 times I to the -1, that's going to equal just 1. So what's the easy way to think about this? We know that I is equal to the square root of -1. I to the second is equal to just -1. I to the third, we can simplify just writing it as -I. Then I to the fourth is equal to 1. And what's going to happen essentially at this point is every time I write I, let's say I to the fifth, I to the sixth, I to the seventh, and I to the eighth, well, I can write I to the fifth as I to the fourth times I. Well, I already know that I to the fourth is 1. So I can write this as 1 times I, and 1 times I is going to be I. I to the sixth, I can write as I to the fourth times I to the second. I know that I to the fourth is equal to 1. I know that I squared is equal to -1, so that's going to equal -1. I know that I to the seventh is equal to I to the fourth times I to the third. I know that I to the fourth is equal to 1. I know that I to the third is equal to -I, so 1 times -I is -I. I know that I to the eighth I can write as I to the fourth times I to the fourth. And I know that I to the fourth is 1, and I to the fourth is 1, and 1 times 1 is 1. So you find that the pattern from above here is going to keep repeating. So we have kind of a rule for this. Okay, so if we want to find the value of I to any whole number exponent, divide the exponent by 4, take the remainder, and then sub the remainder for the original exponent, and then solve. So, and if you need to stop the video to take this down, feel free to do so. I'm going to work through some examples of this, just kind of down and dirty real quick, to show you what this is going to look like. So let's take a look. So here are some problems. Suppose I have something like I to the 32nd. So I want to write this as being equivalent to I to some other exponent. So if I take 32 and I divide this by 4, that's going to go in exactly 8 times. It's going to give me a remainder of 0. So if I put a 0 in there, we didn't talk about that, but I to the 0 is actually equal to the same thing that I to the fourth is, which is equal to 1. Just like anything raised to the 0 exponent equals 1, the same applies for I. So just remember, this is kind of a property for yourself that even when I is raised to the 0 exponent, that's also going to be equal to 1. If I have another problem, let's take I raised to the 42nd. I want to find what it's equivalent to. So I to the 42nd, I'm going to take 42, divide that by 4. 4 goes into 42 10 times, with a remainder of 2. So I to the 42nd is equal to I to the second, which is going to equal -1. So these are things that you have to remember, these properties for yourself. Let's take a look at another problem. Let's take a look at I to the 9th. I want to find out what I to the 9th is equivalent to I to what. So I'm going to take 9 divided by 4. It's going to go in 2 times, have a remainder of 1. So I to the 9th is equal to I to the 1, which is just equal to I. It's also equal to the square root of 1, but we just write that as I. Finally, if I take something like I to the 63rd, and I want to know what it's equivalent to, I'm going to take 63 and divide that by 4. That goes in here once. 4 goes into 23 5 times. That gives me a remainder of 3. So I to the 63rd is equivalent to I to the 3rd. And the value of I to the 3rd is equal to -I. And that's going to be the equivalent form. If you have any questions about this in class, please feel free to ask. But hopefully the concept doesn't seem too difficult and you can watch it a few times if you need to. I will see you in class soon. Have a good night.